Hello, hi bro. Welcome to the student the brand. So this is our sir. Today we are going to discuss about electric current, CBSE grade 10 physics. Electric current. So what is electric current? The flow of charge. The rate of flow of charge is called electric current. I equal to Q by T. I equal to Q by T. The rate of flow of charge. SI unit of current is ampere. SI unit of current is ampere. So capital A. And the SI unit of charge is coulomb. SI unit of charge is coulomb. And SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second. So SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So that is called electric current. Electric current. I hope it is very clear. Okay. So now we can see. So in the conductor, so this is the conductor. So number of charges, positive charge, negative charge, positive charge, negative charge. There are many charges are moving. There are many charges are moving. Okay. So inside of the conductor. So only if it is one electron goes, we can't say current is flowing. Only two electrons flows, we can't say current is flowing. There are many charges are moving inside of the conductor. So that is known as quantization of charge. Q equal to plus or minus Q equal to Ne. So we can take N is the number of electrons, C is the charge. So charge on electron 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 1 by 1.6 into 10 power minus 19, that is 6.25 into 10 power 18 electrons are present. 6.25 into 10 power 18 electrons in 1 coulomb. So these two are very, very important. So you have to learn. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross-section area per second. That is 1 ampere. And charges are moving inside of the conductor. There are many charges are moving. So it's not only 1 or 2 electrons. There are many charges are moving. Okay, so that's why Q equal to Ne. On 1 electron, 1.6 into 10 power minus 19 coulomb. In 1 coulomb, 1 by 1.6 into 10 power minus 19 electrons. In 1 coulomb, 6.25 into 10 power 18 electrons are present. Okay, so it's very, very important. And next, we will discuss about electrical potential and potential difference. Okay, so let's start. Electrical potential and potential difference. electrical potential, okay. So here electrical, so potential difference we'll discuss, then electrical potential, okay, potential difference. Okay, then potential difference, potential difference. So what is potential difference? Potential difference is nothing but potential difference, work done to bring unit positive charge from one point to another point within the conductor. Potential difference is nothing but, so I am taking here, so this is the one point and this is the point B, point A and point B. We are doing some work to bring unit positive charge from one point to another point. So W is the work, Q is the charge. So V equal to W by Q. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So SI unit of potential difference is Joule. SI unit of volt. SI unit of potential difference is volt. And SI unit of work is Joule. And SI unit of charge is Coulomb. 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. Is called potential difference. V equal to W by Q. That is potential difference. Potential difference means within the field between 2 points. Whereas electrical potential, coming to electrical potential, work done to bring, so here this stuff, so some point I am considering infinity. Suppose I am taking this infinity. This is the infinity point. So this is the required field. So we are bringing the positive charge. We are doing some work to bring unit positive charge from infinity to the required field. From infinity to the required field is called electrical potential. So potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Coming to electrical potential, work done to bring unit positive charge from infinity to the required field. So same formula, V equal to W by Q. So 1 joule of work is done to bring 1 coulomb of charge. So 1 joule of work is done to bring, so 1 volt equal to 1 joule of work is done to bring 1 joule of work is done to bring 1 coulomb of charge. Okay, same formula we can take. I hope it is very clear. Okay. So potential difference. This is a potential difference. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. That is called potential difference. Electrical potential. Work done to bring unit positive charge from infinity to the required field. That is called electrical potential. I hope it is very clear to you all. Right? Next. So next we'll discuss about electrical elements, that is cell, battery, switch. So we'll discuss all those points. Now we can see cell, battery. So this is cell, positive terminal, negative terminal, cell. And the second one is battery, positive terminal, negative terminal, battery. And the next one, third one, switch. So open switch, and next one, closed switch, closed switch, closed switch. Cell, battery, open switch, closed switch. And next one, fifth one, resistor, and a rheostat. Rheostat either like this we can draw, or we can also draw like this. Like this. Rheostat. Okay. Cell, battery, open switch, closed switch, resistor, rheostat. So cell, battery, open switch, when it is connected in the circuit, automatically it will be open circuit. When it is connected this one in the circuit, it will be closed circuit. And a resistor. Resistor is a device which is used to oppose the electric current in the circuit. SI unit of resistance. Resistance is the phenomena of opposing the electric current. SI unit of resistance is ohm. And a symbol we can take. And coming to the rheostat. Rheostat is a device which is used to regulate the current, alter the current without changing the voltage source. So regulate the current or alter the current without changing the voltage source. Cell, battery, open switch, closed switch. Resistance is the phenomena of opposing the electric current. SI unit of resistance is ohm. Symbol. Resistor is a device which is used to oppose the electric current in the circuit. And coming to the rheostat, which is you alter the current by connecting. So this is about electric current. And next one, so ammeter, voltmeter. Ammeter, voltmeter. The next one, wire joining, wire crossing. Ammeter, voltmeter. So wire joining, so wire crossing. Wire crossing. Okay. So that's enough. So So ammeter is a device which is used to measure the current by connecting in the circuit. Ammeter is a device. So ammeter is used to measure the electric current in the circuit, electric current. So ammeter will measure the current. Okay, it will be connected in series combination. So coming to voltmeter measure the potential difference. And voltmeter is connected in parallel combination. Voltmeter is to connected parallel combination, okay, to measure the potential difference. So I hope it is very clear to you all. Okay. Okay. Now you can observe. So ammeter, voltmeter, wire joining, wire crossing. Next one, electric circuit. Electric circuit. A continuous and closed path of an electric current is known as an electric circuit. So here, just now I explained, right? Bulb symbol is like this. This is a bulb symbol, so glowing bulb, because we are connecting. So battery. So battery I am connecting. Battery is here. Switch. So current is passing. Positive terminal, negative terminal. So bulb is glowing. Okay. So here you can observe. So bulb is glowing. This battery, switch. Okay. Now you can check once. You can check here. Here conventional current and electric current. Conventional current, and second point is electric current. Coming to conventional current, so the flow of positive charges is known as conventional current. So conventional current is nothing but, so positive charges are moving. Okay, so we can take the flow of positive charges. Positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal to positive terminal. Okay, so electrons are moving. Hi everyone, welcome to the class. So positive charges are moving from positive terminal to negative terminal, whereas electrons are moving from negative terminal. Okay, so positive charges, negative charges. Conventional current. So the flow of positive charges is known as conventional current, whereas electric current is nothing but flow of electrons. Flow of electrons. Electrons will move from negative terminal to positive terminal. That is called electric current. Conventional current is nothing but flow of positive charges. Okay. So this about electric circuit definition is the flow of current moves in a closed path. Okay. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. Electric circuit definition is a continuous and closed path of an electric current. So continuous without breakage in a closed path, current is moving. So then we can say that is called electric circuit. Okay. A continuous and closed path of an electric current is known as an electric circuit. So I hope you got it. Conventional current and electric current. Right? Now, so we'll discuss about okay. Now, so we will discuss about electric current completed, electric circuit completed, potential difference and electrical potential also completed. Now, so we will discuss about Ohm's law. Ohm's law. So Ohm's law is nothing but, so first of all definitions we will discuss. Definition. Okay, so coming to Ohm's law definition. Normally, so we are taking the resistor here. So switch and ammeter. Here ammeter I am taking, and battery. Okay, 1, 2, 3, 4. 4 cells. So voltmeter, positive terminal, negative terminal, current is flowing. So current always moves from positive terminal to negative terminal as according to the definitions we are considering. Electric current definition. Okay, so here how many cells? 1, 2, 3, 4. 4 cells. Okay, so each time you have to connect one. So one by one. First next 2, next 3, next likewise. You have to connect one by one. So Ohm's law definition. Ohm's law definition. The potential difference across the ends of the given metallic conductor. The potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. So at constant temperature, okay, at constant temperature, the potential difference so V is directly proportional to I at the rate of constant T. So V is directly proportional to I. So coming to definition, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it at a constant temperature. So V is directly proportional to I, V equal to IR, and I equal to V by R, and R equal to V by I. Okay, So here you can observe V equal to IR, I equal to V by R equal to V by I. Okay. So that is about Ohm's law diagram. Now we can see materials required. Materials required. Materials required. First one you have to take 4 cells. 4 cells. So each cell 1.5 volts of each. Each cell potential difference is 1.5. Okay. And nichrome wire is an ally of nichrome wire. Nichrome wire is an ally of nickel, chromium, manganese and iron metals. It is a combination. And it's actually 0.5 meter length. Coming to length. And ammeter. So ammeter I am taking. Next, fourth one, voltmeter. And the next one, fifth one, switch. Switch I am taking. So this is switch. And the next one, connecting wires. Okay, so these are the materials required. And the next one, procedure to do Ohm's law. Procedure is first you have to connect one cell. And note down the reading of ammeter and voltmeter. Next, connect to two cells. And still note down the readings of ammeter and voltmeter. And connect to three cells. And still note down the reading of ammeter and voltmeter. So repeat the process for 3 and 4. So we can write here itself. Repeat the process for 3 and 4. First you connect one cell. And note down the reading of ammeter and voltmeter. Connect to two cells. And again note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4. And measure the values of ammeter and voltmeter. Okay. So now mention the values in the tabular form given below. So serial number of cells, ammeter reading I, voltmeter reading V by I, that is nothing but R value. V by I is nothing but R value, right? Yes. So 1, 2, 3, 4. 4 times you have to take readings. First connect one cell and note down the reading of ammeter and voltmeter. Connect to two cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4 and mention the same value. So mention the values in the tabular form given below. Now you can draw the graph for VI graph. The graph is straight line for ohmic conductors. The graph is straight line for ohmic conductors. For non-ohmic conductors, it is curve. So non-ohmic conductors, So for ohmic conductors, the graph is straight line. Okay, so it will be like this. For non-ohmic conductors, the graph is curve. So what do you mean by ohmic conductors? Ohmic conductors are nothing but the conductors which obey Ohm's law. Those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. The conductors which obey Ohm's law, those are called ohmic conductor. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. So this is the graph. Once again, observe Ohm's law. At a constant temperature, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Okay, so V equal to IR, I equal to V by R equal to V by I. And materials required 4 cells, 1.5 volts each, nichrome wire 0.5 meter length, ammeter, voltmeter, switch connecting wires. Procedure: connect one cell and note down the reading of ammeter and voltmeter. Connect 2 cells and note down the reading of ammeter and voltmeter. Repeat the process for 3 and 4 and mention in the tabular form given now. And the next one, so draw the graph for V. The graph is straight line for ohmic conductors. Ohmic conductors, the conductors which obey Ohm's law, those are called ohmic conductors. And the graph is curved for non-ohmic conductors. Okay, so you can check once here. That's enough. I hope it is very clear. Now, so we'll discuss about resistance and resistivity. So now, resistance and resistivity. Resistance and resistivity. So R is directly proportional to length of the conductor. R is inversely proportional to area of the cross section. R is directly proportional to L by A. R equal to rho into L by A. And here rho equal to RA by L. Rho equal to RA by L. Okay. So now we can observe here. SI unit of resistance is ohm. Symbol I am taking. And here SI unit of resistivity is ohm meter square by meter. Meter get cancelled. Then ohm meter. SI unit of resistivity is very important. So in exam they may ask for 2 marks. So definition is very important. At the same time, derivation of SI unit. SI unit of resistivity. So this is very important. 2 marks question they may ask in the exam. So keep in mind. So how we have to derive, you have to remember that one. So first if you get this one, automatically you'll get resistivity formula and definition. And here you can observe resistance depends on length and area of the cross section. So here depending factors Here temperature, common points are temperature. Second one is material. And here also temperature, and this is material of the conductor. Okay, so you can observe here resistance depends on length of the conductor and area of the cross section, area of the cross section, and temperature of the conductor. Resistivity solely depends on temperature and material, so it does not depend on length and area. Okay, so these are the depending factors and the difference between resistance and resistivity. Now, so we'll discuss about so resistors are connected in series combination and resistors are connected in parallel combination. Resistors are connected in series combination. Resistors are connected in series combination and the resistors are connected in parallel combination. Now you can observe here R1, R2, R3, V1, V2, V3, okay. So now you can observe here. So in this case R1, R2, R3. So three different resistors are connected in series combination. Current is same. Throughout the circuit current is same. Potential difference is different. And resistance, three different resistors. Now from Ohm's law, V equal to IR. So here I S equal to I1 equal to I2 equal to I3 equal to I, because throughout the circuit current is same. Okay, so now Vs equal to V1 plus V2 plus V3, then IRs equal to IR1 plus IR2 plus IR3. Now I am taking I common. If you are taking I common, R1 plus R2 plus R3. So I get cancelled. Rs equal to R1 plus R2 plus R3. So resistors are connected in series combination. So if n number of resistors are connected in series combination, Rs equal to Nr. Okay. So now we will discuss about resistors are connected in parallel combination. Resistors are connected in So resistors are connected in parallel combination. So now you can see. So ammeter, so R1, R2, R3. So here across I1, I2, I3, and here is I, and here also I. So in this case, potential difference Vp equal to V1 equal to V2 equal to V3 equal to V. Potential difference is same. Now, so we can take from Ohm's law V equal to IR, I equal to V by R. So IP equal to I1 plus I2 plus I3. So V by RP equal to V by R1 plus V by R2 plus V by R3. So we am taking common 1 by RP equal to we am taking common 1 by R1 plus 1 by R2 plus 1 by R3. VB get cancelled, then the remaining values are 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if n number of resistors are connected in parallel combination, then 1 by RP equal to n by R, then RP equal to R by n. So this is about n number of resistors are connected in parallel combination. So I hope it is very clear. Just check once again. So here you can see. So voltmeter is connected across R1, R2, R3. Ammeter. So battery, switch, current is passing. Here current is dividing I1 through R1, I2 through R2, I3 through R3. Then potential difference is same. So through R1, R2, R3, potential difference is same. Vp equal to V1 plus V2. So Vp equal to V1 equal to V2 equal to V3 equal to V. So that's why, but current is different here across resistor. So that's why IP equal to I1 plus I2 plus I3. V by RP equal to V by R1 plus V by R2 plus V by R3. So V common, VV I am taking common, 1 by RP equal to V I am taking common. 1 by R1 plus 1 by R2 plus 1 by R3. V get cancelled, then we'll get remaining 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by RP equal to N by R, RP equal to R by N. I hope it is very clear. So this is about resistors are connected in parallel combination. Now, Now, so you can observe resistors, electrical power. Simply we can say heating effect of electric current. Okay. So V equal to W by Q, W equal to VQ, and so here rate of doing work is called VQ by T, V into Q by T, that is I. So VI. Now we can observe electrical energy equal to P into T, that is VI into T. V equal to IR. Yes or no? So IR into I into T. Then whatever the energy is given to the conductor, that will become in the form of heat. H equal to I square RT. I square RT. Okay, heat produced in the conductor is directly proportional to square of current. Heat produced in the conductor is directly proportional to resistance. Heat produced in the conductor is directly proportional to time. Okay, so heating effect of electric current is also known as Joule's law of heating. So here you can observe one thing. Heating effect of electric current is nothing but the source of energy continuously gets dissipated entirely in the form of heat. Whatever the energy is given to the conductor, the total energy continuously gets dissipated entirely in the form of heat. That is called heating effect of electric current or Joule's law of heating. I hope it is very clear. So thank you so much for joining and attending, listening my class. If you like the video, if you like the channel, if you like my explanation, do like, share and subscribe to Student in the Brand. Thank you so much. We'll see you in the next class.